Okay, so 11:6, we're moving into a new figure. Before we always did like, here's the lateral area of these two different figures, and then here's the surface area of these two different figures. Now we're doing lateral area and surface area both, but just for a sphere. Surface area and volume of a sphere, no lateral area. Does anyone know why there's not lateral area in a sphere? It's round. So what is missing? There's no bases, right? If there's no bases, you can't add two bases on to get the surface area. So your surface area is just the whole surface as is. So there is no lateral area formula. Keeping in mind, so here's all your formulas at the end of class today. Don't do it right now. But at the end of class, you're welcome to take a picture of that and use that to study. That's the quiz you're going to take on Tuesday. So if you want to take a picture, take one at the end of class, not right now. So spheres. If we have a sphere that looks like this, this circle is called a great circle. Great, as in wonderful, great. And a great circle is just the circle that would cut it into two equal hemispheres. That's an I. Okay, so you'll have two equal hemispheres if you have your great circle. That great circle is where your radius and diameter are going to fall in a sphere. So you'll still have right through here, okay, that would be a diameter. This half of it would be a radius. So you have to use the great circle to use diameter and radius, okay? We're going to start with surface area. And with a sphere, my best representation for you for this is a baseball or a softball. If you think about, let's just show you the formula first. The formula is 4 pi r squared. When you look at that formula, there's pi r squared in there. What is pi r squared? It's the area of a circle, right? So we're saying 4 times the area of a circle. So if you think about a baseball, the leather used for a baseball, that's horrible. Still not great. The leather used is 2 pieces like that are identical. It's really bad. But if you think about it, you have a circle here, a circle here, a circle here, and a circle there. And when we put those together, it's the one piece of leather goes like this, the other piece of leather goes like this, and it makes a sphere, right? So 4 circles kind of all put together to get your surface area. So the first thing we're going to do is just find the surface area of a sphere. This is one of the 2 types of problems you're going to see on your quiz on Monday. I will give you a sphere and either give you a radius or a diameter, and you have to figure out what is its surface area. So for this one, I'm going to give you a diameter of 8 meters, and we're going to say find the surface area. Okay, the formula is 4 pi r squared. What is r? Radius. What is it in this picture? It's the 4, okay? So if we're saying 4 pi r squared, it's 4 times pi times the radius, which would be 4 squared. You're just going to plug in the numbers, not the pi, okay? So 4 times 16, that would give us a surface area of 64. Then attach your pi. How would you label surface area? Square meters, okay? So be careful today because you're going to have square meters and cubic meters because you're doing surface area and volume. So just make sure you're keeping those separate, okay? Questions on that? So just make sure you're using a radius. If they give you a diameter, you need to cut it in half. If they give you a radius, you're good. Just plug it in. You good? Okay. Second example. This one takes a little more thought. we're going to talk about Earth, which I know is an oblate spheroid. I hear it every year. It's not a sphere, but we're going to pretend it's a sphere, okay? And say the equator of Earth. That's not what I want. What? Right.
It's flat. You're a flat earther? It is flat.
Cricky, if I could send you on a rocket.
I'm not a flat earther. I'm open to the possibility that it is flat.
See, the earth is flat. It's weird that you need to believe that.
Yeah.
No, I'm just kidding. I don't believe that. I don't believe that.
Wow. Okay, that's a discussion for a different day. The equator is 24,902 miles long of Earth. For the time being, we're considering Earth to be a sphere. So if that's the equator, what are we talking about when we talk about the equator?
A straight line.
It's not the diameter. It's the great circle. It's the circumference, right? So if I know the equator of Earth is 24,902, you could say that's my circumference of Earth, okay? I want to know what is the surface area of Earth. What do you need to find surface area? You need the radius, right? So in order to find the radius, we have to use the circumference to do that. How can we do that? What's the formula for circumference? Pi d or 2 pi r. I feel like we typically use pi d, so we'll go pi d right now, even though 2 pi r would be probably the better option. But we know that 24,902 is equal to pi d, because it's the circumference, okay? How do you solve for the diameter? Divide by pi. So we're going to divide by pi on both sides here and say our diameter, we're just going to say is approximately, because it would be. So 24,902 divided by, turn the calculator on. 24,902 divided by pi. You get a diameter of 7,926.553. Okay? What were we looking for? Surface area, which requires what again? A radius. So if that's a diameter, how do I make it a radius? Cut it in half. So if you divide by 2, and I'm just dividing the number that was in my calculator. So this number right here is not perfectly divided by 2. But if I divide by 2, I get 3,963.276 for my radius. Okay? The question was, what's your surface area? So you're going to take that radius and you're going to plug it into the surface area formula. So we're going to say the surface area is 4 times pi times 3,963.276 squared. Okay, so you plug that into your calculator. This has already been rounded, so there's no point in trying to leave it in terms of pi, because in terms of pi would be an exact answer, and we can't have that anymore. So we're just going to plug it in. 4 times pi times 3,963.276 squared. And we're going to round here to the nearest, what did we say, 100,000. Okay, so the number I got is this, 197386978. If I round to the nearest 100,000, that would be right here. Is that number going to stay a 3? It's going to become a 4, okay? So we would say Earth's surface area is 197,400,000. And we were talking miles, square miles. Okay, so you need a radius, solve for the radius. It's not worth shaking your head about. Volume is our next thing here. Volume of a sphere. Your formula This one tends to give people a little bit of trouble for two reasons. Number one, it's 4/3, not 3/4. And a lot of times, I don't know why people need their fractions to have a smaller number on top, because it's just not true. You don't have to have a smaller numerator than your denominator. So it is 4/3, which means when you plug it into your calculator, if you're not using a fraction key, you're plugging in 4 divided by 3, not 3 divided by 4. Okay, so make sure it's 4/3 is the first thing that usually throws people off. The second thing is you are cubing it, not squaring it. So remember, surface area is units squared. That's the one that has radius squared. Volume is units cubed. That's the one that has the radius cubed. Okay, so cubed for volume, squared for area. Allure.
Do we have to like press enter when we put the 4 divided by 3?
You can write 4 divided by 3 times 7 to the 3rd power. You can just plug it straight in. Yep. Okay, so let me give you a sphere. This is example number 3. Let's say our sphere has a radius of 6 meters. Okay, so if I want the volume of this sphere, it's already a radius for you, so you don't have to cut it in half this time. But we're going to say volume equals 4/3 times pi times that radius to the 3rd power. Okay, again, you're going to plug this into your calculator. So 4 divided by 3 times 6 to the 3rd, and you get a volume of 288. Maybe you want to plug that into your calculator to just double check that that's what you're getting. And it's volume, so cubic meters. Okay. It does not get any simpler than that. You didn't have to solve for anything, right? You're just plugging a number into a formula. So those number 1 and number 3 are about as basic as you can get with these. This 4th example takes a little bit of working through things. I'm just going to show you, there is a way to plug this into your calculator in one step, but I confuse people every year when I try and talk them through it because it's a lot of parentheses and a lot of like, make sure you do this and then this and that. So I'm just not even going to show you that. If you want to see that way that you could plug it into your calculator straight, ask me and I will show you. But it feels like more of a headache than it's worth to 90% of you. So I'm just gonna show you how you'd break it down the other way. And if you want to see the one swoop calculator way, you let me know. All right, here it is. We know the volume of a sphere is 5,000 cubic meters, okay? I want to know for that same sphere, what would the surface area be? Now, look at your volume and surface area formulas. What is the common piece in them? The radius, okay? Our radius is unknown, or our radius is our variable for both of them. So what we're going to try to do is take the radius out of our volume and put it into our surface area, and then we'll know the surface area of that same sphere, okay? So the way we do that, our volume formula is 4/3 pi r cubed. So we're going to plug in what we know, which is this 5,000. So we're just going to put the 5,000 right here. 5,000 equals 4/3 times pi times the radius cubed. Okay. So the part that gets confusing for people on these problems is the algebra. So I'm just going to re-talk you through the algebra for solving this. There's a few ways you could go about it. You could break it down like one little piece at a time, or you can do it slightly less little pieces at a time. What would you do right now to solve for r cubed? What would your first step be?
Divide 5,000 by pi.
You would start by dividing by pi. Okay, you could do that. Who else? What would you do? What? You can't take the cube root yet because you have to get that other stuff out of there first. This is PEMDAS in reverse now because we're solving for the R. So you can't cube root it yet. You got to do the multiplication and division first. I'll just tell you what I would do first. You don't have to do this, okay? But what I would do first, just to keep my numbers nice as long as possible, is I would multiply by the reciprocal here. So I would multiply by 3/4. Okay, that's going to get rid of the 4/3. So you're going to plug into your calculator 3/4 times 5,000. Okay, when you do that, you get this number. 3,750 equals pi r cubed. Okay, now there is a way to plug the pi in right away at the beginning. That's the way I'm not going to show you because that's the way that always confuses people. But you could, okay? Instead, I break it down in 2 steps. So from here, what would you do now to solve for r cubed? Divide by pi. Okay, now our number is going to get a little ugly, but that's okay. So divide by pi. 3,750 divided by pi is this number, 1,193.662. Okay, so we have r cubed. Is there an r cubed in surface area? No, so we have to figure out what r is. We can't just plug that number in because we need an r squared. Do you know how to get r? That's what Madison was talking about, right? We're going to cube root that number. So the cube root, you got to find this button on your calculator. If you don't know how to cube root, let me talk you through. You will either have this button on your calculator, or it might look like this on your calculator, but it's a button where you get to either put the 3 in or they've already put the 3 in for you. My guess is most of you, it's this one, the first one. If that is you, if you have that button, it should be right by your square root button. It's usually like right below it. You need to put the 3 into your calculator first. So if this is you, you would plug in 3 and then hit that button and then type the number 1193.662 in. Okay, try that and see what you get. If you have this one, you just need to hit that button and then type the number in. You don't need to put the 3 in because the 3 is already there for you. Okay, but you should get this number. That's rounded. Okay, 10.608 would be your radius. Everyone getting that? If you're not, talk to me in a little bit and I will walk you through it. Okay, so now you have your radius and we're looking for surface area. So now it's a very quick step. You just plug it in. So surface area is 4 times pi times the radius squared. Okay, so you plug in 4 times pi times 10.608 squared. And you get a surface area. If we're going to round to the nearest whole number, 1,414. And we were talking meters, so square meters.